Welcome! Today we're going to look at programming design. So, when we're going to try to program the VEX robots to do different things, generally it is behavior-based programming. You have three different types of behaviors. You have complex behaviors, lots of different things happening, and simpler behaviors. Simple behaviors make up complex behaviors, and then basic behaviors make up the simple behaviors. So we're going to walk through all those. And then there's also bad behaviors, but we won't talk about those. So here's a complex behavior. You have this super complex thing here going on. You hit a button, some lights flash, the fan goes on, then another light goes off once you hit the button again. So the first thing you'd want to do in this is create pseudocode. And pseudocode is just the everyday generic language that you would use to write out what you're going to do. So we break it down. Here's an example. If you want to turn the motor on for 3 seconds, then you want to, you want to follow a line until you run into a wall, turn on a motor for 3 seconds, follow a line until running to a wall. We're going to break that down a little bit further. So for this, let me go back again here. For this little doohickey here, you got this fan. It's kind of like a fan, sort of a fan. Not really. And then a button and some lights. A warning light would come on before the fan starts for 3 seconds. So the light comes on for 3 seconds. Then the fan turns on and runs until the button is pressed. And then a different light turns on for 3 seconds before it stops. I guess it's not really a great program because, like, if it was cutting someone's arm off, it'd be 3 seconds. 1, 2. So there's basic behaviors, which are also like baby steps. It's so cute. Alright, so here's your program example. The program would begin. Then you would want light number 1, LED 1, to turn on for 3 seconds. This is a great example of pseudocode. Then you want the fan to turn on until a button is pressed. And then you want the light 2, LED 2, to turn on for 3 seconds. Then the program ends. So we're going to see what this would look like in actual code, but this is your pseudocode. It just explains what's going on. Now you're going to want to make sure, and I think we just walked through this whole thing with motors and sensors set up, and we did ours where it was automated. You clicked on the Sim POE button and it filled in. I'm pointing to my screen, you can't see that. It fills in all the little things in there, which is actually over here on this side. Alright, so here is an example of this. Here's your task description. Fan will run until someone needs it to stop. There's a warning light for safety before the fan turns off, and another to indicate the fan is stopped. So your pseudocode, we just read through all this. And then what is a great thing to do here is you take your pseudocode, you copy it, and you paste it into your task main. And you can see that there's a double slash. Double slash means it comments out. Again, that means it's just not reading any of that. That's just notes for you. And the slash star will comment out all of it until you get to the star slash. So that's why all of that's in green without the double slashes. So we're first going to identify all the inputs and outputs. So this would be if you did it manually, which you're going to have to do down the road. They put in the motor port, they put fan motor. That's what they're calling it. You want it to always be descriptive. Don't just call it like motor 1. Call it something that it's actually running. And I believe ours, we wouldn't call it motor equipped. It would be a 269 motor. Then in the you would go over to the digital sensors here, and you'd put in your LED 1, LED 2, and then your bump switch. And they make it a touch switch. So we'll use the debugger to confirm everything's working. So all the codes, this is kind of how yours are all going to be set up. You're going to always copy and paste this from here all the way down to here, and then your task main. So right now, if you're going to write your first code, you would have, and you've done all your debugging, so hopefully you know what 63 for a speed on this motor means, how fast that is. But we start motor, wait 5 seconds, and then stop motor. And that would be a very simple task code for motor for 2 seconds. So all of your code needs to be within the task main. That is the beginning of the task. Everything here on the top is the configuration changes. So if you set up a motor and you call it write motor, it will show up here. When we do our block code that was the sim and POE and motors and sensors, it puts just one line on here that says sim and POE that has all your motors and sensors configured. But when you do it manually, you'll see each individual one up here. So then again, task main with a double open close parenthesis followed by a curly brace, and all your code will be in between these two curly braces, as it says down here. The 63 would turn the port 2 write motor, we've identified it as write motor, on at half power. Remember, full power from your chart was 127. Hopefully you found that. Then we're going to wait for 5.0 seconds. Always follow every line by a semicolon. You note that in all these. And then we stop motor and we tell it the right motor. You don't have a speed when you stop, so that's why there's not a comma after that one. So there's your time. Then we stop it. End result, right motor spins for 5 seconds. So you could test this out if you wanted to. Copy and, well, you can't really copy and paste, but you could type that into your ROBOTC and run it, and you would see it run for 5 seconds. Now, program design is always done this way. You have basic behaviors, and they would come together to make a complex behavior. So your basic behavior is turning the motor on for 5 seconds. But that might be part of a larger system. You have one motor running for 5 seconds while another one is flashing lights. So you got a lot of things going on, but each one is a very simple basic behavior. So you want to troubleshoot them as basic behaviors. So if we want to do this where, remember the beginning part of this was the LED turns on for 3 seconds, and then the motor turns on until the button is pressed. That was our beginning program. So if you look here, this is the only code that it's running. Here's your first question. You can pause this after I ask it. Why would this code here not be red? What do you see that indicates it's not red? Did you say because it has 2 slashes? Because you're right. So this is not red. So really we're commenting out everything else except for this, just so we can see if that first part of the code works. Turn LED on, wait 3 seconds, turn it off. So once we know that works, then you can comment that out. So this time we commented using the /* and the */ above it and below it. So it's going to be very helpful for you if between basic behaviors you leave, like line 40 and 41, you leave empty blanks, because then you can easily put your * and then your /* to comment it out. Now next time you compile this and download it, it's only going to run start motor, and the motor's name is fan motor. It runs at full speed, 127. Until bump, that's another code that we haven't yet learned yet, but you'll get to that. Until bump means it won't go any further until bump. And then the name of that's a bumper, and then after it bumps, then it will stop the motor. And they used until bump. But your code could say until bump, or it could say until touch. Until bump means push in and out, click in, click out. Until touch just means click in. So there's times that you might want to do that. And one thing just to make sure that you have set up, and I remind you this in the document, is you should click Robot, Platform Type, Innovation first. Make sure it's always on Natural Language, Vex Cortex. And yours actually looks a little different than this because we have an updated version. So it should say Natural Language, Vex Cortex. I don't believe the word library is there, but that's kind of what you're looking for. Natural Language, Vex Cortex, every time. Now over here on the far left hand side, once you have it there, if you push F5, that will compile and download a program. If you push F7, then that just saves it. And that will bring up all of this code here. It says natural language. If you click that plus, let's go back to that. It opens up robot motion. Set up movement special. This is all of your code. We're not using robot motion for really any of our stuff. So I'm going to go over to movement. You're going to use movement all the time. So if you want to figure out how do I actually write the code? What are the words? Go over here to the far left side, the function library in ROBOTC. And if you click the movement tab, then you can actually click and drag start motor into your code. And it will put it in there. Then all you have to do is change the words motor port to whatever you call it, right motor, and speed to a number like 127 or 63 if you want a half speed. Same thing for stop motor. You can click and drag it in there. And set servo, which we'll get to. Now, we didn't really do much with reversing polarity. You can reverse it by clicking this in the motors and sensor setup, the reverse thing. You can also change it by changing the sign from positive to negative. And the third way you can do it is the actual plugin. If you put the reverse the plugin, then it will reverse polarity. I would never really suggest doing that. I would always keep it, when you look at the plugs, the solid blue to solid blue, and you flip it over and you see the little metal to metal. So if you always keep it that way and all you ever deal with is this positive negative, things are going to run a little bit more smooth because you don't have to worry about, well, which way did I plug it in? Special functions, if you wanted to turn a flashlight on, you can click and drag this in there, or you can just start typing turn flashlight and it will sort of predict what it is that you want to type in there. Same thing for LEDs. Where it says digital port, you'd actually put the name that you called it. And I think the SIM PoE generic naming convention was green. I think is what they call it because they use a green LED. There's some of the until ones. If you want to use until bump, or the other one I was talking about was until touch. And there's a bunch of other ones here. Until we will never use until button press, so just get that one out of there. But if you want to use until sonar is greater than, if you want to put something in front of the sonar, we get to that one. And then here's your wait. Most of the time you're using wait, not wait in milliseconds. Wait, and then it's in seconds. So if you want a half second, you put wait 0.5. Wait states accuracy. Your motor will be affected by the battery power. So if you want to let a motor run for a certain amount of time because you think in a distance and you put, hey, I want it to run for 2 seconds because it goes this far, tomorrow it probably won't because your motor speed is affected by your battery. So if you say 2 seconds today with a full battery is going to be probably farther than tomorrow if you get a semi-charged battery from another group. So weights are a little bit finicky with that. Usually you can make out, okay, there is a better way, and that's using encoders. And so that comes a little bit later. So touch sensors, your buttons, you have this one down here on the bottom, and then you have this other button way up here on the top. If you push it in, it turns it into a 1 in the computer. If you release it, it turns it into a 0. So here's your caution. Bouncing can occur when a sensor is pressed or released. If you push that button, it might go 101010, where it bounces between 0 and 1 very quick. And if that's the case and you say until bump, then turn the motor on, until bump again, turn it off, it might go on, off. And then you never even saw the motor turn on because it read that bump switch twice really quick. So if you want to eliminate that problem, which I would suggest you do every time, you can put a very brief wait. Here would be the example. Until bump, wait 0.05, 5/100ths of a second. That's plenty because you push that button quick, push, and then it's waiting 5/100ths of a second before it reads that next line. You won't have bouncing. That's it.